All right, guys, so the first thing I'm going to do is try to talk a little faster and left some of the stuff. I did this video once and it came out to be 17 minutes. I can't have that much time. So what I have done is I have graphed all of these points and this is what they look like. Now, if you were to take a guess, just a guess at where the line of best fit, the line that's going to be closest to all of these dots without doing something really strange like, oh, connect all the dots, uh, that's not a line of best fit. So not a good idea. Don't do that. All right. So if I go with what I have and I want to guess, I don't like guessing because there's a lot of work in guessing. I don't know who's right. I've had kids come to the board and draw what they think is the line of best fit. They drew it on their paper. I would replay it up on the board and say, this is what somebody has. What do y'all think? So if I go with what I have, this slope, it looks like it's kind of going up one over one, but it's slightly dropping every time. Between the first two, it really looks like it. So if I were to guess, the M could be 1. The B, that's where it hits. Remember, this is the y-intercept, and the y-intercept here hits at 1. So if I were guessing, I would say, well, it's 1x plus 1. And if I did that, then I would figure that right here, when I plug in an x is 10, I would say, well, it's 10 plus 1, which is 11. So my answer is 1 comma 11. And to estimate an R value, these look pretty close, pretty tight. I'm going to guess a 0.8. Now, the more of these you do, the better you get at guessing. Because what we're going to do is we're going to put it in the calculator. And you know what? I wanted to do this ahead of time in the calculator so we wouldn't have to. And if you go to data, you'll see that I don't have this information. So I'm going to hit data again and hit number 4 because it clears everything. And I'll show you the next time I do it why that works if I haven't shown you yet. So 1, enter, 1.5, enter, 2, enter, 2.5, enter, 3, 4, 4.5, 5, 5, 5.5. And then the second line, you have to go up and you arrow over and you hit 2, enter, 3, enter, 2, enter, 4, enter, 3, 5, 4, 5, 6, and 6. And I hope that's last. Yay, we got it to the end. So second, data. And I'm on 2 variable stats. Hit number 2. Do not hit number 1. Enter, enter, enter. And I'm going to scroll up because it's closer to go up until I get to where it has D, E, and F. So D, E, and F has my A is 0.83. A equals 0.83. B equals 1.67. 1.67, and R is 0.9. All right, so if I have these, that means the real values, the right answers. I'm going to do them in green. The right answers using these. Now, notice it's an A. That takes the place of the M. So this is 0.83x plus 1.67. And my R is actually a 0.9, which is even stronger than, this is positive, positive answer, positive slope, positive and strong correlation. So you just had your first example of what this can look like. You may go, that looks kind of weak to me because it's not all on the line or they're not right beside the line. That's okay. This 0.9 means it's strong. So what I want to do is show you real quick what weak and strong looks like. So in the middle you have 0. And then you have 0.5, and negative 0.5. Think of this like a number line. And it's a reflection. And negative 1 is a perfect line where everything is right on top of it. Positive 1 is a positive line where all the points are right on top of it. We have this in-between stage that is at about 0.8. Now, guys, this is statistics and everything is not hard and fast, but this is considered weak and you can't tell if it's going positive, if it's going negative. These are really, really weak. Let's do it in yellow. Weak. Boom. The next one I'm going to do is moderate. Let's do that in this gray area. Gray and gray. This is moderate. And guys, this is perfectly symmetrical on choosing down here. Oops, I want to do this. What's up here on either end is very strong. So this is strong. And guys, whatever the slope is positive or negative, that's the same as the correlation coefficient as far as positive and negative goes. Strong. There we go. Weak, moderate, strong. That you may want to go back and look at this little symbol because that just straightens everything up tremendously. Okay, now we're going to go on down and do the next problems. And I have filled this in for you. I went ahead and found all of this information, but I did promise that I would show you how to clear it out on your calculator. When you go to data, if you want to clear all of it, hit data again. See how they have 1, 2, 3, and if you arrow down, because the arrow was down there, that means there's more information. It says clear all. You can just click on number 4. And I know I can do that every time. So when I put this information into data, here's the information that I got. Okay, and I did not want that to come up. Here's the information that I have. I found out that A was negative 0.42. B is this. Here is my R. And now I'm going to use Y equals AX plus B as opposed to MX plus B because that's what the TI-30 multiview does. All right, so I'm going to have negative 0.42X plus 5.34. Now remember, the B is your y-intercept, which is hitting about here, and that looks very believable that that could create my line of best fit. All right, notice it's going as time goes by, it's going down, so that's a negative slope. All right, so here's your negative slope. Here's your negative slope right here, and that's our y-intercept. If we want to find out when x is 10, what is the value? We would plug it in right here and we put it in the calculator, which is going to be, it's going to be 4.2 is what, just take this and put it right in the calculator. I'm doing it in my head as I go. So I get 10, 9.54. I'm sorry, that is a negative number and it is not 9.54. That's what I get for doing it in my head. All right, so it's going to be 1.14. 1.14, which makes more sense than 9 because 9 would be an outlier. That would not work. All right, so our estimated R value, this is not an estimate. This really is. It's a 0.68. Remember our list from above, 0.68 is moderate. The fact that it's negative meant I had a negative slope. One more. So this is all the information that I have. I've got it graphed, and I would say it's a positive correlation, and I have not put this information in my calculator, so I'm going to put it in as quick as I can. 1, 1.5, 2, 3, and that's not what I meant to hit. I somehow hit a plus. Enter. 3 again. 4, 5, 5. 6, 6. And my refrigerator's yelling at me. That's funny. 2.5, 4, 3, 3, 5, 4.5, 5, 5.5, 4, and 6. Got it entered. Second, data, 2 variable stats. I hit number 2, enter, enter, enter. Okay, got my information. Scroll up. I need the A, the B, and the R. I got off the thing there. There we go. So 0.46, 2.56. I'm going to write this down. 0.46, 2.56, 0.72, because I can't remember them. All right, so love it when this happens. Okay, I have A is equal to 0.46, B is 2.56, and R is 0.72. All right, so y equals ax plus b is going to be 0.46x plus 2.56. That is my equation. If I want to know when x is 10, I would have 0.46x plus 2.56 and plug in a 10 right here. So it's 4.6. That's going to give me, I started not to do it, 67.16. All right, so that means I would have an estimated value. If I were going to put a point in where x is 10, this would be an approximate value. Now, this is actually used a lot in statistics. The R correlation coefficient is 0.27. And this is actually moderate. So when it's moderate, we can't rely on it a lot. It's not strong. It's definitely moderate. It is positive because this is a positive number, shock and all. This is also positive. All right, I hope this helps you. Have a good day.